To determine if an electrical service is overloaded, several steps need to be taken, focusing on calculations and understanding the implications of exceeding the service's capacity. Firstly, converting kilowatts to amps is crucial. In this case, 61.5 kilowatts is divided by the voltage, which is 208 volts in a three-phase system. The formula used is power in kilowatts divided by voltage equals current in amps. 61.5 kilowatts divided by 208 volts equals approximately 295.7 amps. Secondly, calculate the percentage loading on the current service. This is achieved by dividing the calculated current, 295.7 amps, by the rated capacity of the service, which is 200 amps. 295.7 amps divided by 200 amps equals 1.4785, or 147.9%. Now consider the analysis. A service loaded at 147.9% is significantly over its recommended capacity. Electrical codes and best practices typically advise against continuous loading beyond 80% of a service's rated capacity. The 80% rule is a guideline to prevent overheating, voltage drops, and premature equipment failure. In the situation described, the service is clearly being pushed beyond its limits. To effectively communicate this information to the customer, follow a structured approach. Firstly, explain the situation clearly. Inform the customer that their current 200 amp service is overloaded based on measured power usage. It's essential to use simple, understandable terms. Secondly, provide data to support the explanation. Present the measured 61.5 kilowatt demand and the calculated 147.9% loading. This data validates the assessment and demonstrates the severity of the issue. Thirdly, discuss the potential consequences of overloading the service. Explain that an overloaded service is at risk of overheating, which can damage wiring and equipment. Voltage drops can occur, affecting the performance and lifespan of connected devices. There is also a risk of premature equipment failure, leading to costly repairs or replacements. Fourthly, recommend a service upgrade. Suggest upgrading to a 400 amp service to provide adequate capacity for current and future electrical needs. This recommendation should be framed as a solution to the identified problem. Fifthly, emphasize the benefits of an upgraded service. Highlight that an upgraded service improves reliability, reducing the risk of electrical issues and downtime. It provides a safer electrical environment. It also allows for future expansion, accommodating additional electrical loads without overloading the system. Several additional factors should be considered. Firstly, factor in any future plans the customer may have. If the customer plans to add more electrical equipment, such as additional kennel equipment, grooming stations, or climate control systems, the new service must be sized to accommodate these loads. Secondly, perform a detailed load calculation. A comprehensive load calculation based on the National Electrical Code, NEC, will determine the actual electrical demand. This calculation accounts for all connected loads, demand factors, and any applicable diversity factors. Thirdly, consider the type of equipment being used. High-demand equipment, such as air conditioners, heaters, and specialized kennel equipment, will have a more significant impact on the electrical load than low-demand items like lighting. Fourthly, think about the efficiency of the equipment. Newer, more energy-efficient equipment can reduce the overall electrical demand. Replacing older, inefficient equipment with newer models can help manage the load. Fifthly, analyze the power company's data. Review the power company's billing data to understand peak demand and usage patterns. This data can provide valuable insights into the electrical consumption of the facility. Sixthly, inspect the existing electrical system. A thorough inspection of the existing electrical system can identify any potential issues, such as undersized wiring, damaged components, or code violations. Seventhly, check the voltage levels. Monitor the voltage levels at various points in the electrical system to identify any voltage drops. Voltage drops can indicate an overloaded circuit or an inadequate service. Eighthly, ensure compliance with electrical codes. All electrical work must comply with the latest edition of the National Electrical Code, NEC, and any local codes or regulations. This includes proper wiring methods, overcurrent protection, and grounding. Ninthly, document everything. Maintain detailed records of all calculations, inspections, and recommendations. This documentation can be valuable for future reference and liability protection. Tenthly, seek professional advice. Consult with a qualified electrical engineer or licensed electrician to perform the load calculation, assess the existing electrical system, and recommend the appropriate service upgrade. Considering the load calculation, several factors should be analyzed in detail. Firstly, determine the general lighting load. Calculate the lighting load based on the square footage of the building and the lighting requirements per square foot, as specified in the NEC. Secondly, calculate the receptacle load. Determine the receptacle load based on the number and type of receptacles in the building, as specified in the NEC. Thirdly, calculate the HVAC load. Determine the heating, ventilation, and air conditioning HVAC load based on the size and efficiency of the equipment. This includes the cooling load and the heating load. Fourthly, factor in motor loads. Calculate the motor loads for all motors in the building, including those used for pumps, fans, and other equipment. Motor loads can be significant, especially during startup. Fifthly, account for special equipment. Include any special equipment used in the dog kennel, such as grooming equipment, kennel heaters, and other specialized devices. These loads should be calculated based on the nameplate ratings. Sixthly, apply demand factors. Apply demand factors, as permitted by the NEC, to account for the fact that not all loads will be operating at the same time. Demand factors can reduce the overall calculated load. Seventhly, calculate the total connected load. Sum all the individual loads to determine the total connected load. This is the total amount of power that could be drawn if all equipment were operating simultaneously. Eighthly, determine the maximum demand. Apply the appropriate demand factors to the total connected load to determine the maximum demand. This is the highest amount of power that is likely to be drawn at any one time. Ninthly, compare the maximum demand to the service capacity. Compare the maximum demand to the rated capacity of the existing service. If the maximum demand exceeds 80% of the service capacity, a service upgrade is recommended. Tenthly, size the new service. Size the new service based on the maximum demand, taking into account any future expansion plans. The new service should have sufficient capacity to handle the current load and any anticipated future loads. Some specific electrical code references include Article 220 of the NEC, which covers branch circuit, feeder, and service calculations. Table 220.42 provides demand factors for general lighting loads and various types of occupancies. Table 220.44 provides demand factors for receptacle loads in non-dwelling occupancies. Article 430 of the NEC covers motor circuits, motor overload protection, and motor short circuit protection. Article 440 of the NEC covers air conditioning and refrigeration equipment. Table 310.16 provides ampacities of insulated conductors rated up to 600 volts. Table 310.15 provides ampacities of conductors based on dating factors for ambient temperature and number of conductors in a raceway. Regarding communication to the customer, it is important to be professional and clear. Firstly, use clear and concise language. Avoid technical jargon and use terms that the customer can easily understand. Secondly, provide a written report. Prepare a written report that summarizes the findings, calculations, and recommendations. This report provides a clear and documented record of the assessment. Thirdly, be prepared to answer questions. Be prepared to answer any questions the customer may have about the assessment and the recommended service upgrade. Fourthly, offer multiple options. If possible, offer multiple service upgrade options to provide the customer with choices. Fifthly, obtain a signed agreement. Obtain a signed agreement from the customer before proceeding with the service upgrade. This agreement should clearly outline the scope of work, the cost, and the schedule. When considering the existing service, it is important to evaluate several factors. Firstly, verify the service size. Confirm the actual size of the existing service by checking the main breaker or fuse. Secondly, inspect the service equipment. Inspect the service equipment, including the main breaker, meter, and wiring, for any signs of damage or deterioration. Thirdly, check the grounding system. Verify that the grounding system is properly installed and in good condition. A properly grounded system is essential for electrical safety. Fourthly, assess the panel capacity. Determine the number of available spaces in the electrical panel. If the panel is full, a new panel may be required as part of the service upgrade. Fifthly, evaluate the wiring. Assess the condition of the existing wiring. If the wiring is old or damaged, it may need to be replaced as part of the service upgrade. Furthermore, it is important to know the potential risks of overloading an electrical service. Firstly, overheating can occur, which can damage wiring, insulation, and equipment. Overheating can also lead to fires. Secondly, voltage drops can cause equipment to malfunction or fail prematurely. Voltage drops can also reduce the efficiency of electrical equipment. Thirdly, equipment damage can result from voltage drops, power surges, and other electrical problems caused by an overloaded service. Fourthly, fire hazards are a serious risk with overloaded electrical services. Overheated wiring can ignite nearby combustible materials. Fifthly, safety hazards exist, including the risk of electric shock or electrocution due to damaged wiring or faulty equipment. In addition, the benefits of a service upgrade are substantial. Firstly, increased capacity is the primary benefit, allowing the customer to add more electrical equipment without overloading the system. Secondly, improved reliability reduces the risk of electrical problems and downtime. Thirdly, enhanced safety protects against electrical fires, electric shock, and other hazards. Fourthly, code compliance ensures that the electrical system meets all applicable codes and regulations. Fifthly, future expansion allows for the addition of more electrical equipment in the future without requiring another service upgrade. Moreover, when planning for future needs, consider the following. Firstly, anticipate future growth. Estimate the future electrical needs of the dog kennel, taking into account any planned expansions or additions. Secondly, consider energy efficiency. Encourage the customer to use energy-efficient equipment to reduce the overall electrical demand. Thirdly, plan for electric vehicle charging. If the customer plans to install electric vehicle charging stations in the future, factor in the additional electrical load. Fourthly, think about renewable energy. Consider the potential for adding renewable energy sources, such as solar panels, to reduce the reliance on the utility grid. Also, it is important to be aware of the costs associated with a service upgrade. Firstly, equipment costs include the cost of the new service panel, breakers, wiring, and other electrical components. Secondly, labor costs include the cost of hiring a qualified electrician to perform the service upgrade. Thirdly, permit fees may be required by the local municipality for the electrical work. Fourthly, inspection fees may be required to ensure that the electrical work meets all applicable codes and regulations. Fifthly, downtime costs can be incurred while the electrical service is being upgraded. There are several options for service upgrades to consider. Firstly, a 400 amp service is a common upgrade for commercial buildings with moderate electrical demands. Secondly, a 600 amp service may be necessary for larger buildings with higher electrical demands. Thirdly, an 800 amp service or larger may be required for very large buildings or industrial facilities. It is vital to choose a qualified electrician for the service upgrade. Firstly, verify the electrician's license and insurance. Ensure that the electrician is licensed and insured to perform electrical work in the area. Secondly, check references and reviews. Check the electrician's references and online reviews to get an idea of their reputation and quality of work. Thirdly, obtain multiple bids. Obtain bids from multiple electricians to compare prices and services. Fourthly, review the contract carefully. Review the contract carefully before signing it to ensure that it clearly outlines the scope of work, the cost, and the schedule. In summary, accurately calculating the electrical load, clearly communicating the findings to the customer, and recommending an appropriate service upgrade are crucial steps. By following these guidelines, the customer can make an informed decision about upgrading their electrical service, ensuring safety, reliability, and sufficient capacity for their current and future needs. It is also beneficial to understand three-phase power. Three-phase power is a type of alternating current, AC, electrical power distribution that uses three conductors instead of the single conductor used in single-phase power. This results in a more efficient and balanced power delivery system. Firstly, three-phase power is more efficient than single-phase power, delivering more power for the same amount of current. Secondly, three-phase power provides a more stable and consistent power supply, reducing voltage fluctuations and improving equipment performance. Thirdly, three-phase power is commonly used in commercial and industrial applications due to its efficiency and reliability. The 120/208 volt system refers to a three-phase, four-wire system where the voltage between any two phases, or legs, is 208 volts, and the voltage between any phase and the neutral wire is 120 volts. This system is commonly used in commercial buildings to provide both 120 volts for lighting and small appliances, and 208 volts for larger equipment. In this specific scenario, with the dog kennel upgrading to 400 amp, 120/208 volt, three-phase service would provide a significant increase in capacity, allowing the customer to safely operate existing equipment and add new equipment in the future. The decision to upgrade the service should be based on a thorough load calculation, an assessment of future needs, and a clear understanding of the benefits and costs involved.